Good evening. Welcome to DevOps for Defense. So we're gonna get started tonight. I'm very excited about our speaker this evening. We're gonna welcome Hans up to talk about developer productivity engineering in just a second. But as always, I'd like to start by just running through our code of conduct as usual. Obviously, look around you. This is an unclassified environment, so please no dirty words in this forum. Treat each other with respect and professionalism. Don't talk about your secret sauce. Nobody wants to know it. Just keep that to yourself. But do talk about your experiences and what you need and how you can improve. Share your thoughts and help others in our community as we try to all improve together. Make sure we're learning and sharing together. And as always, the guys here at Rocket, they let us use this place for free. They help us get all this stuff set up. They're really great to us. So on your way out, please make sure you show some respect to them as well. We would very much appreciate it. A couple of short, quick announcements. The guys at the Huntsville AWS Meetup have an event coming up that they asked me to mention. They're going to be talking about containers and Kubernetes and cloud. And if you've been with us for the last few months, these should all be something familiar to you. Looks like a pretty good opportunity to get some hands-on looks at some of these technologies and how to take advantage of them. So you can go out and search up for them, the AWS Huntsville PhDs Prime Huntsville Developers. It's a mouthful. But Tuesday, March 10th, they're going to have an event. Feel free to check it out. And of course, next month, I'm very excited. We've got GitLab coming into town. GitLab is obviously a Git-based configuration management repository. They specialize in automation and integration of CI/CD into their platform. So they've got some neat stuff going on. They're going to come talk to us about what they're doing. And with that, let me quickly hand it over. I'd like to introduce Hans Gradle. Hans is the founder and CEO of Gradle Inc. What? Hans Dockter. Holy cow. We should change your name. Anyway, Hans Dockter's out here. He flew out to see us from Silicon Valley. It's absolutely amazing, the support that he's shown to our community to come out and do this. So with that, let me hand it over to Hans. Thank you very much.
Cool. Thank you. So, let's see. Yeah, thanks everyone for coming. How is the audio? Loud enough or? Louder, okay. Then, let's see. I'm wondering whether I should get the mic closer to my mouth or whether we turn up the volume. How is it now? Is it better? Okay. Let me know when I should, because there's some background sound. Let me know when it's getting too quiet. So I need to switch presentations quickly. Here we go. So, yeah, my name is Hans Dockter. I'm the founder and CEO of Gradle. And today, I don't want to talk so much about. Oh, this is getting a very challenging. Okay. So how do I do the demos later on? I might get a share. Let's see. Have to practice a little bit. So if I later do some demos and I sit like this, okay, I can sit like this. Okay, that's the thing. Here we go. In the previous room, the projector was at a different place. So, okay, that will work. So I just have to stand here. So I don't want to talk so much about a particular technology, but I mostly want to talk about developer productivity and about the practice of making developers more productive by applying engineering, right, to that discipline, right, applying data, applying acceleration technologies. But before we get started, I want to talk a little bit about why that is important, right? So developer productivity, needs toolchain effectiveness. What do I mean with that, right? So when I started with Gradle originally, right, our business model was primarily consulting. So So we work with Wall Street banks, we work with Apple, LinkedIn, Netflix, with Raytheon and defense. And so we were in the trenches with hundreds of organizations doing software development at scale, right? And what we learned, right, is that their tool chain effectiveness, right, the range goes from mediocre to bad to terrible, right? As soon as software stacks have a certain size, we see a lot of pain out there, right? And we got used to a lot of that pain, which is not necessarily a good thing. So we want to talk about the cost of that pain and the cost of inaction, and how can we make stronger business cases to get approval to invest into developer productivity. And there are straight economic arguments. We will talk about that later on, right? When someone is waiting half of the day for something to finish, obviously you lose a lot of valuable R&D resources. But there's another very important point. When you have passionate developers and they feel that they could be much more productive in a different environment, right? That makes them really unhappy. So making your developer team more productive is not just an economic benefit. It significantly increases the happiness at the workplace, at least for the people you want to keep the most, right? And I always like to share that story. There was a fireside chat with a Wall Street executive and an executive from Netflix. And the Wall Street executive was saying something like, or if we only had the quality of your engineers, we could do all that kind of amazing stuff. And then the Netflix executive was saying, guess where we got them from, right? From your organizations, right? And that is what I know Netflix is doing, right? They do not recruit primarily in the Bay Area. They recruit on the East Bay, right? They go to Atlanta, to Boston, and present at the Java user groups, but also make a strong point what a great environment Netflix is for developers to be productive. And it's a key reason why they are successful with recruiting. So one thing that is important to understand is the bread and butter workflow of developers, right? So software development is a creative discipline, but it's not the creativity of the artist. It's more the creativity of a scientist. So when you think about a scientist has a hypothesis and then enters a dialogue with nature via experiments to see is that hypothesis correct or not. And then either evolves the hypothesis or whatever the result of the experiments is. We as software engineers do something very similar. Our hypothesis is the code, right? So we have a couple of lines of code or whatever, right? And now we need to enter a dialogue with the toolchain. Hey, compiler, what do you think? Hey, unit test. Hey, integration test. Hey, check style. What do you think about my change? Is that hypothesis valid, right? And then you get the feedback, right? And so that loop is the most important loop when you're doing development. And when that loop is slow, right? When it takes a long time to get a response, or when that response is not reliable, when you often get responses, hey, your hypothesis is wrong, but actually there's a bug in the test case, then you have a productivity problem because you lose a lot of time because of that, right? So, and when you look at, when kids get into software development, imagine when you started to do your first coding, right? And let's say you draw that circle in blue and then you change the color to red. Imagine that would take 10 minutes. Who of you would now be software developers, right? So that was the fun why we got really hooked up, because we had a tool chain that was super responsive, it was correct, and so that's why I think most of us, that's why we loved software development, right? And now we are enterprise software developers, right? And life has changed, right? So, but I think we are used to too much pain. We have accepted too much of those inefficiencies, and it's time to do something about it, right? And so we talked about a very important part of developer productivity, that is the speed of the feedback cycles, right? Extremely important. You ask the question, you want to have a fast response, right? From a lean production point of view, right? The time that is between the response and the answer is waste, right? In some form or the other, right? So you're creating waste, right? The longer this response takes. So, but we're living in a world where I often talk with organizations, right? And then they say, I ask them, hey, what about feedback cycle time? And then they say, it's not a problem. Then I ask them, what is your average feedback cycle time? And they say 4 minutes, 8 minutes, 9 minutes, whatever. And then I ask them, what if we could cut this down in half, right? And then they answer, well, it's not a problem for us. So what do you mean it's not a problem? You know what they mean with it is not a problem? No one is complaining about it. That's why it's not a problem, right? So, but obviously, so they're not driven by kind of all the savings they can get from that. As long as no one is complaining, we're good, right? And that is not a very mature state. That is not how many other industries are driven. They're constantly looking for improvements. So, but now it's obvious, right? I worked with some code bases. I was involved with some code bases where it took 14 hours to get feedback for any kind of change, right? Everyone in such a team knows it's a big pain, right? But let's look at smaller teams, right? Can everyone read that in the last row? No? And is the volume still okay? Should we ramp it up a little bit? Yeah. Thanks. Okay. So put your earplugs on first. How is it now? Is it better? Awesome. Thanks, JD. So now we're looking at a small team. For them, let's say they change a line of code, and then to build all the changes, to test all the changes, it takes 4 minutes. So who of you here has slower feedback time than that? Right? Most, I would assume, right? Okay, so everything is good for those guys, right? So they're basically in paradise. So now let's do some experiments, right? This is real data, right? So we looked at another team at the same company, 6 developers. Their feedback cycle time was 1 minute. Now what do you see? Right? The team with the 1 minute time is asking twice as often for feedback than the other team. So you can see that the 4 minutes is already changing their behavior, right? And not to the better, right? A big part of agile development, right, is feedback. Small changes, feedback. Small changes, feedback. And you can see even 4 minutes is already changing their behavior, right? And my favorite experiment, we talked about it this afternoon. So mentally, you get used to the 4 minutes. So you know when you start that process, when you run the builds and the tests, you already know it takes 4 minutes, and your mind is whatever doing, right, wandering off. But you somehow deal with that, and it doesn't feel like 4 minutes necessarily. If you would do pair programming with another software developer, and you would work together, and then the two of you together would wait for those 4 minutes, you would feel how long those 4 minutes are. It is fascinating experiment. It's like, oh my God, that takes actually a long time. I have not realized that before. Let's do that experiment, right? So you can see that faster feedback cycle, people they're more in a creative flow. But of course, there's another important aspect with those feedback cycles, right? Let's say you wait for something that takes 1 minute. What do you do during that minute? Nothing, right? Yeah, exactly, right? And that is even, so, no, and that's good. I mean, you have to do something, but then often finishing an article on Reddit takes 4 minutes. You know what I mean? So that kind of context switching is or you're going on Twitter or you read something, but even with the 4 minutes, there's not much productive you can do. Not much productive stuff you can do. So there is quite a bit of research that when you wait for something that is faster than 10 minutes, right, a lot of that time is waiting time, is unproductive time. So, and we all have that. right? So, but if I would ask you, and that applies to almost every organization on the planet, if I would ask you, hey, you developers, how much time did they spend last week on waiting for the test, on waiting for the compiler, on waiting for that, right? Could any of you give me an answer? No, right? Because we don't have the data, right? So let's take this team with 1 minute build time. Let's say you were here, 6 people, right? No, 7, right? But you were part of that team, and I would ask you, hey, I think there's a way to get this 1 minute build time down to 0.6 minutes, right? And then you need to give me an answer whether we should invest, let's say, 2 weeks of work into that. How can you give me an answer whether it's worth it? It's hard, right? Gut feel wise, it doesn't feel like, gut feel wise, it feels like 1 to 0.6 minutes. Is that a big difference? Shouldn't we rather focus on features? And that's where we have to talk about data, right? So with a team of 6 developers, we measured, they ran 1,010 builds per week. Now we can do some simple math. We get the build time down from 1 minute to 0.6 minutes times 1,010 times 52, and that saves them 44 days. Now we have a conversation. If that effort would take me 6 months, no, we shouldn't do it. If that effort takes me 2 weeks, right, we should get started tomorrow, right? But we need to have that kind of data to make those decisions. We cannot go by gut feeling. It's ridiculous. So it's such a complex environment, and we still go by gut feeling how we should prioritize this kind of stuff. It's just impossible, right? It's like me shooting with an air rifle as a rocket defense system or something like that. It will not work. So for bigger teams, the situation is even more dramatic, right? When you have feedback cycle times like 9 minutes, right? And you run 100 engineering team, 100 developer team runs 12,000 builds per week, right? Getting the time down from 9 minutes to 5 minutes saves you 5,200 days. Now think about it, 100 developers, let's say 220 working days a year. That's a little bit more than 20,000 working days. That's 25% of their R&D capacity they waste on waiting for stuff. But they've been doing that for the last 20 years, right? So everyone else is doing that, so what is wrong with that? Well, 5,200 days, right? And I'm not, so that's how we have to talk about that stuff, right? And that's how we have to talk with the business, with the decision makers, right? That is a language, the people who write the checks, that they understand, right? And we have to talk in that language. If we're just saying, oh, we're so frustrated because things take so long, well, it's a very different conversation. So, but actually, there's a very cheap way to avoid this waiting time, right? You don't need to invest 2 weeks or whatever. You just make everything take longer than 10 minutes, then no one waits anymore for the stuff to finish. They do context switching. Isn't that the solution? No one is really convinced. I'm disappointed. I expected like, wow, this is the best idea I've ever heard, right? So, no, of course, it's not the solution. Context. So let's say you have now processes that take 15, 20, 30 minutes, right? Or you have, something that takes 10 hours. Of course, people do not wait for that to finish, right? They switch to different tasks. So let's say when you look at the happy path, you finish a feature, you create a pull request, or however you do that, right? And then the pull request build is successful, it gets merged into master, fine. That's kind of a fire and forget situation, right? And when your feedback cycles are very long, you might get into serious merge conflict situation. But in general, it's fire and forget. But the happy path is only one path, right? As soon as the build fails, right, you left the happy path. So let's say this pull request build took 30 minutes, right? You switch to a new task. Now you get an email, your build failed. Okay, you have to switch back to the other task, have to understand why did the build fail, then very often you said, I have no idea why it failed. let's run it again, let's switch back to my new task again, then it fails again. Oh, let's switch back here. I still don't know why it fails. Oh, I need to contact the CI/CD team to help me, or maybe you figured out why it failed. But this context switching there's a lot of research. It costs heavily, right? It is hard for the brain to get deep into a new context. And when we talk about 30 minutes or 60-minute feedback cycle, we're not just talking about one context you do in two contexts you do in parallel. You might work on A, wait an hour, then you work on B, that is also running, then you work on C. Some people deal at the same time with 4, 5, 6 different things, and it severely affects the productivity, right? Every context switch might easily cost you 10, 15, 20 minutes, right? In terms of productive time. So, and of course, an unreliable tool chain significantly increases that cost. So let's say you have an average build and test time. Your pull request build takes 20 minutes, right? But 20% of those, or let's say, my math is leaving me. So I said 20 minutes. Okay, and then 20% of those pull request builds fail because of a flaky test, which means you go there, you look at it, and you run the build again, right? Then your average build time is 20 minutes plus 0.2 multiplied 20 minutes. Because in average, you need to run 1.2 builds, plus your time to understand what is the problem, right? So the reliability of the tool chain is has a huge impact on build time, and also needs to be measured, right? So the other problem is when you have a situation like you have a pretty long feedback cycle time, right? Let's say 30 minutes pull request build, 45 minutes, and oh my God, all those flaky tests. I see many situations where it takes people easily half a day to a day until they get a green pull request build, for all different kind of reasons, right? Is that something that resonates with you? I don't know, right? So oh my God, right? The tax to get something merged is high. So what is your behavioral change? The stuff you try to get through will become bigger, right? The ideal way in an agile world, make all the small changes, then get feedback, right? Doesn't work here, right? If it takes you 4 hours in average to get something merged, right? You cannot work with super small increments, which you otherwise would do. So your change set gets bigger. And again, when you're on a happy path, that's not a problem. But when something fails, it becomes much harder to debug, obviously, right? When you have a change set that has now, where you have touched 100 or 200 classes, yeah, it makes debugging much harder, right? So the longer the build, the more developers try to push in one build PRCI cycle, the bigger the change set, the harder to debug. And there is good research around that the time it takes to fix a defect grows exponentially with the time it takes to detect the defect, right? And that is one reason, because the change set gets bigger. Now, one thing that I'm seeing more and more, right, as our code bases are growing and tool chain complexity, the build time increases, right? And I mentioned that today we were working with that company that was having 25, 30 minutes build and test time. And the developers were saying, well, we cannot run this anymore locally, right, before we move on to something else, right? It just takes too long. So they established a task force to try to make everything faster. So that task force cut off 5 minutes of the build time. So they went down 20, 25 minutes. It was far from where they wanted to be. And the VP was involved. And so at one point, they did something. What do you think? What is a possible decision they might take to make the local build very fast? An organizational decision. Any idea? Stop running the tests. Right. And the build time is now under 5 minutes. Right. So now they just get feedback from the compiler. So they lowered the local quality gate. So they're doing the opposite from continuous integration, right? And now the only first the only real feedback they're getting is from the pull request build, which means more failed pull request builds, more, more CI congestion, all of that, right? And there's only one way out of that problem. You have to make things faster. It's that easy, right? Or that hard, but that is the only solution, right? How can you make feedback cycle time significantly faster? And that is valuable whether your build takes 1 minute, 4 minutes, or 20 minutes, right? The thing is, we looked at the 1 minute scenario, right? Getting a build time down from 1 minute, build and test time to 0.6 minutes, it will not change, it will change the behavior slightly, right? Getting build time down from 20 minutes to 3 minutes, that will change, that should change behavior drastically, and we'll look at that. So how do you can get the build time down? So for me, just a quick show of hands, who of you is a Java developer here? So who of you C++? What are the other folks doing? Who is not developing code? Right. So any other language represented here? JavaScript, Python, yeah. Webpack, npm. Yeah. Yeah. Got it. So Webpack now also ships with a build cache. We will talk about that. So a key concept I want to introduce here, and that is relevant for Java. It's relevant for any kind of build activity. Is the concept of caching, right? When you look at whenever you have a code base and you build and test it, right? That happens in multiple steps, right? When you have a big Java build, it can easily be 10, 20,000 separate steps, right, that are executed as part of one execution, right? But even if you have a small team, a small project, right? I know we did some experiments with SLF4J, simple logging for state for Java, 13,000 lines of code. Even building that is about probably something like 150, 200 steps, right, to build the whole thing. So this is now Java specific, but the same. So when you have a bigger repository, or even when you have a smaller one, right? Usually your code should be modularized, right? So that is how that would look like with Maven or with Gradle, right? You have a multi-module build, right? And those modules are built, independently in the order of their dependencies. They are tested independently, and that is where all the steps are coming from, right? In C++ it would be the same. One is a library, the other is a consumer, would be the same thing. So, and the idea of a build cache, it's very different from a dependency cache, like Nexus or something like that. A dependency cache caches is basically represents a dependency to another source repository. Those modules here, they are part of a single source repository, right? And you always build them together. And the idea is that any build action, right, has inputs and outputs. And the idea of a build cache is, when the inputs have not changed, why don't you reuse the output of a previous build, right? So the idea, let's look at an example, right? You have a build step, a compile build step, right? And you usually have more than one per build. Oops, sorry. So the compile step has inputs. What are the inputs? Obviously the source code, right? But also the class path, the compiler configuration, the Java version. CMake something similar, right? And what a build cache does, it hashes all those inputs, right? So it's not timestamp based, it's really content based. It hashes all those inputs, and then it creates a key that uniquely represents those inputs, right? And then the cache client asks the build cache, do you have output for that key? Meaning basically, was that built before? And if the answer is yes, you download the output. In the case of the compile task, it would be the .class files, right, for Java. And you don't execute the compile step. right? You just unpack the output into the build output directory, that's it, right? So, and the same concept applies to test, the test step, right? The test step has inputs, the source files, runtime class path, Java version, right? And the outputs are the test results. Check style has inputs, outputs are the check style reports, right? Documentation generation, source code generation, all those things have input and have output. And all those inputs you can analyze, and with that key that represents the input, you can retrieve output if it hasn't changed. So when you run builds on CI, right, you always run clean builds, right? So regardless of what has changed, you build everything again. You test everything again, right? And so that's how it looks like, right? This kind of, when you have 5 modules, right? In this example, generate sources, compile, check style, compile, test, you have 25 build steps. You always run those 25 build steps. But what if I have changed only the export API module and no other module depends on that? Why the hell do I need to build this over and over and over again, right? From an engineering point of view, it looks pretty wasteful, right? And it is, right? So with the build cache, right? Let's say the build starts with building generate sources or compiling the core module, right? Well, we analyze the inputs of the core module, we calculate the key, we ask the build cache, do you have output for that input? The build cache says yes. Here's the output, boom. Don't need to execute compile core. The same is true for check style, compile, test. When I arrive here, right, I calculate the key, I ask the build cache, do you have output for that input? The build cache says no. Okay, then I need to run compile, I need to run check style, I need to compile the test, I need to run the test, because the test class path has changed. But I only needed to run 4 out of 25 build steps. It's huge, right? And what you will, and of course, if you have dependencies, right, that will trigger a bigger rebuild, but it will still be a partial rebuild. And like in this case, right? So the effect of that is tremendous, right? So many of you probably know the Spring Boot project, have heard about that, right? So even if not, doesn't matter, it's a very popular, one of the most popular Java open source projects, right? It's around microservices. The project itself has 300,000 lines of code. So compiling and running the unit test for Spring Boot takes over 20 minutes on my machine, right? At least that was a couple of months ago. Fully cached, we get this down to under 2 minutes. So that changes everything, right? So now no one can say, oh, I don't want to run this locally. Of course you run this locally before you run a CI build, right? And you can run it much more often so that you are much more effective. Your change sets get smaller, right? That is what is possible for many software stacks with caching. If you look at the SLF4J project, this project builds and tests in 30 seconds. So you would say, well, so what, right? It's all good. But fully cached, we get it down to 10 seconds. Hey, and once you're used to 10 seconds, I guarantee you don't want to go back to 30 seconds, right? So even for small projects, it can be very interesting. Another aspect is CI resources. So if you think about what a build cache is doing, it allows your CI infrastructure to use less compute resources. Instead of running the compiler, instead of running the test, it just downloads something and unzips it. So compute resources are traded against a little bit of I/O, right? And so I don't know who of you suffers from CI build queues, that they don't have a CI agent available always when a CI build is triggered. So this is from an organization, right? 150 engineers, developers. 40 to 50% of all their CI builds couldn't start immediately because an agent was not available, right? And by introducing build caching and optimizing the build cache, they got to a point where they had days where not a single CI build had to wait for an agent, right? So that makes developers happy. It makes finance happy, right? Again, so we're not just talking about waste in developer time, but also waste in terms of compute resources if you don't have a smart caching mechanism. And for engineers, it's like it's the most obvious solution in the world, right? I don't know why. Sometimes I wonder, it's 2020, and why are we not doing this for the last 20 years? It's so obvious, right? So one thing that is nice with the build cache is sometimes people struggle to convince developers about paying attention to architecture, to decoupling of modules, to the idea of, hey, let's have a smaller API surface and stuff like that. So a build cache will heavily benefit a well-modularized code base. So imagine you have all your code in 3 modules, and then you will spread it out to 10 or 15 modules. The more modules you have, the more incremental the caching will be. That makes sense, right? So that is so better modularization and build and test performance, they go hand in hand. I skip those. Yeah, the other key thing we need to do to make feedback cycles very fast is how can we make test execution faster? The build cache is one part to the answer because it avoids running tests unnecessarily, right? But of course, you change some stuff with the code base and you want to run the tests for those, right? So how can we make test execution for those faster? And we need a built-in solution, right, for running tests in a highly distributed way, right, without any overhead for the developers to make that work, right? So I don't want to go into the detail. We have something in that area that you basically, whether you run the build locally or you run it on CI, right, we have logic that hooks into the build and then checks how many agents do I have available for running the test, and then we distribute per test class, right, all the test execution on all those agents. And for the developers, it's the same. They just run Gradle test, they just run Maven test. So it happens kind of magically that the tests are executed on multiple machines, and that is, of course, another huge performance saver. What we see that many people duct tape around that, so they're saying, okay, our test execution time takes too long, so let's have 4 or 5 Jenkins jobs. Let's say you have 500 tests, you have a Jenkins jobs, 1 to 100, 100 to 200, the next one. So you manually shard the test execution. First of all, it's nothing the developers can use for the local builds, and second, it's just not a very effective way of doing things. Let the computer figure this out, how to distribute them effectively. Okay, so one big part of improving feedback cycle time is acceleration technology, caching and distribution, right? But that is not enough, right? Because there is a lot of stupid stuff, right, we are doing, right? And when we don't look at the data, we continue to do that, and then all this acceleration technology, all the benefits will be eaten up. To make it a little bit more concrete, we talked about it this afternoon, right? So I share you, it's the same team that had several problems that they were not aware of because they had no data, right? So first of all, so we helped them with build caching. They had a 1200 submodule, a very, very big Maven build, right? So, and with build caching, we could make it already significantly faster, but it was still not super fast. So we start looking at the data, right? And then we were, so we have a way to, and I will demo some of that. We have a way to capture, whenever you run a build and a test execution, to capture a very comprehensive set of data about what happened, right? And one thing, after we were doing this for years, we detected was, do you know that you run most of your integration tests twice as part of a single CI build run? And they were like, what? I mean, this was a huge problem. They had committee meetings because how do we make our build faster? And they were not realizing that in their complex Jenkins pipeline, they were running tests twice, right? So there was one thing. And those were legit engineers, right? And yet, because they had no way to look at execution data, and no one was looking at 300 pages of Maven output, right? that was undiscovered. Maybe one guy made some stupid change with they mixed up the Surefire and the fail-safe plugin with the Maven lifecycle stuff, and then out of a sudden that happened, right? And no one ever looked back. So the other thing, right, they were not aware of is the following. So I just want to show you an example how we capture data. So this is a single build run, and if you're interested, like let's say in the question, how much time did I spend on creating the archives for this project, right? You can just say, hey, show me the time, right? And then we would tell you for this build that took 6 minutes, 6.5 seconds was spent on creating archives, right? On packages. Okay. So, and you can do this for compile, you can do that for whatever you're interested in. So the team we're talking about did that, and then they saw for their CI build, 40 minutes was spent on creating archives. 40 minutes just for creating the jars. It was a big build, 1,200 submodules, but still 40 minutes. Okay. Then they because we also collect data from all the local builds, we looked at a local build. The same stuff was built locally, and it took only 1 to 2 minutes to create all the jars. Any idea what that could be? What the reason for that could be? On their local machine, they had SSD drives. And this was a company that was loaded, right? They already bought more expensive machines for CI to make everything faster. They just had no idea that hard disk had such an impact on build time. I mean, and it's hard when you have a build with 1,200 submodules. You run 10,000s of build steps. It's really hard to, by gut feel, to judge what is taking the time, right? But once you have fine-grained data about each and every build step, and then you can aggregate it, you can answer such questions easily. And they were so happy. For them, it was like eye-opening. They couldn't believe what they were seeing, right? When you tell people, oh, with data, you see so many inefficiencies in your pipeline, I would be like, well, really, I'm not sure, right? Looks like pretty reasonable what is happening at our place, right? But I guarantee you will see interesting stuff, right? And even with this insurance company we also talked about, right? We had a situation, they had a dedicated build engineering team, and they were doing a lot of microservices, and they said, oh, they build super fast, right? 32 seconds to 1 minute. So we plugged in our data collection engine, and then we saw all those fast microservices built. Those were, and even when they were building them locally, they were that fast, right? 30 seconds to 1 minute. But then we saw for the same project, 20-minute build time. And they were like, what is going on here, right? They had 400-500 developers, right, working heavily distributed team, right? What the hell is going on? Why do some of those builds take 20 minutes, right? And then they dived into that and said, wow, some people work from home, dial into the VPN, and using a network share as the build output directory, right? So they compile, the compiler runs basically on their machine, and then every .class file is sent over the network to the network share. That's why it took so long. For those people, it was normal that it took 20 minutes, right? So no one complained. They were okay with that, right? So again, and it was funny, you had a very similar example to share, right? With exactly that type of problem. So I guarantee you 2 things, right? If you collect data, right, you will see interesting stuff. We say, wow, we can make this more efficient. And I guarantee you also that new interesting stuff will show up as your code base evolves, right? So data is key. So, and for me, it starts with, so this was a use case where some people had a experience they shouldn't have had, 20 minutes, right? And in this case, it was about educating them how to avoid that, right? But another situation is, right, where we talk about the whole team, right? So let's say a developer makes a choice tomorrow in your team to add some new libraries, some new annotation processor, something to your tool chain, right? That slows down the compile by 5%. Maybe the guy is adding a Scala module, right? Because love Scala, the compiler is very slow. Right? I see some head shaking here. But you get the idea, right? And then the build is now 5% slower. No one, right, usually realizes that, right? So then 5% here, then 3% here, 2% here, and you can see the slow regression that kind of, you know, while the frog is in the milk and the milk gets hot, you get the idea, right? So on the other side, let's say you are super dedicated, you're going home after this talk, right, and say, damn, I improve my build and test time tomorrow for my whole team. And let's say you improve it by 10%, right? Who will even notice? If you have a team of 100 developers, that might save you, I don't know, $5 million. I don't know, but it will be a significant number, and yet no one even notices that. That shows for me something is wrong. Right? We're talking about a high impact stuff that is completely under the radar, right? And you know about radar. You know what it means when something is under the radar, right? It's dangerous, right? So we should not work like that. Any car company, imagine a Toyota, right? Someone would say, no, I didn't realize that the assembly line slowed down by 5%. This guy would be fired, right? Within, I mean, literally, this guy, that would be it, right? It would be a deep violation of the culture at that company, right? And we need to, we need to move in that direction, right? The other thing is troubleshooting, right? We see so much pain out there. People accept that the build and test pipeline is kind of a pretty shitty experience, to be honest, right? They get this exception, say, well, I haven't seen that before, let's run it again, and if it works, then everything is good, right? So, and people, and why is no one saying, oh, I had this problem, I should report that to some knowledgeable person to fix it? Well, the one key part of the problem is, if I have an issue that is hard to reproduce, that only happens now and then, let's say on my local machine, how do I report it? I can tell you, oh, I have this issue, and you say, well, I don't know, I never had that, right? So can you tell me more? And my answer is no, right? Maybe you come over and we run it 5,000 times, and maybe it comes up again, and then you say, well, maybe I have other stuff to do than doing, and the people with the problem also says, maybe I have other stuff to do, right? So if you don't capture data of each and every build and test execution, right, you will not get in control of those issues, right? So I want to show you another demo just to give you an idea, right, how this could look like. Let's say we have there's an engineer in your team who is saying, let's say his name is Sterling, and let's look at his builds over the last 4 weeks. Oh, I forgot about that one. So let's look at the performance of this. Let's say Sterling is saying, oh, I don't know what the problem is. My builds are very slow now and then. Let's say, right? And you're like, well, for me, they're never slow. They're always okay, right? I don't know what the problem is, right? And Sterling says, okay, whatever, right? Most of the time it's okay. So if you have data, right, about all the build and test executions, you can say, okay, Sterling, right, let's go back. So here are all of Sterling's builds of the last 4 weeks, right? Some failed, some were successful. And now I can have a performance view and can say, okay, which builds took a long time, right? And then I can already look at, I can say maybe it's related to dependency download time. So then I can click dependency download time, and then I see, wow, Sterling actually has a few builds where the dependency download time is very high. So now I click this build. Oops, that's not what And I can go to performance, to network activity, and I can see, yeah, it took 33 seconds here to download the dependencies. Why? His bandwidth was 1.5 megabits per second. Okay? So now the question is it because the dependency download server is slow, or whether is it Sterling internet connection? So you could now look at builds at a similar time, and if you then see, oh, the network the bandwidth was much higher there, then you know Sterling has a bandwidth issues. But the great thing, if you have all the data, you can quickly confirm there is an issue. You can find the root cause, at least something close to the root cause. It's something to do with network, right? And yeah, that's a complete game changer to have all that information available to provide a high developer productivity across your whole team. And one beautiful thing of having data for each and every build is the following. So let's say you have a failing CI build, right? And we show you data about, you know, why it has exactly failed, but let's say you still don't know why it has failed. But what you know is it worked 10 minutes ago and I haven't changed anything, right? So why the hell is the CI build failing? Wouldn't it be great if we could compare the two builds? And that's exactly what you can do when you capture data about each and every build and test run. You can just say, hey, what were the builds that were run before? This one was successful. Let's compare the two. And you can see, oh, a different dependencies. The CI build used version 1.6 of a dependency. The local build used 1.5. Well, you haven't changed anything, you know. Or maybe you, for whatever reason, you know now that is a candidate that might be responsible for that situation. Without this data, how do you investigate problems like that? Right? You will not. You will just run the build so long locally and on CI that they're green again. And you say, oh, we have such an unreliable build pipeline, and the build and the test is shitty. But in this case, everything was okay. This was a legitimate failure, but you never understood why it failed. That's why you run the CI build again, it will still fail. Then you run the local build again, and now, because you might use Maven snapshots, now it might fail as well. You will never know why it actually failed. That means you lose more and more trust in your pipeline and in the feedback you're getting from your tool chain. If you cannot figure out the root cause, you always, at one point you think, oh, it's over, then you start. We work with organizations where the developers were sending around shell scripts that they executed before any build and text execution that deleted any cache on that machine. The library cache, the up-to-date cache, just to be sure, right? that at least it might take a long time, but at least the feedback that I get is reliable. Right? So not good. So that's why we're saying capture comprehensive data of every build and test run, right? And I want to make one more point here, and then I go on. So let's go back to the scans. Let's look at a failed build. That's weird. Ah, that's the wrong instance. Was our demo instance. Again, I want to look at failed builds for the Gradle project, and let's look at this one. So here we have a failing test. Let's say you're running a build locally and you have a failing test and you don't know why it failed. So you want to ask for help. How do you do this? Right. Let's say you have you have a colleague in a different building or whatever, you want to ask for help. So you can tell a person, hey, my test failed, right? Can you help me? Well, of course, I say, I don't know. I need more information. So then you might, what I did in the past, I uploaded the test results to Dropbox. So then the person could look at the test results. Oh, yeah, I'm not sure, right? And then the person asks, what dependencies are you using? What Gradle version are you? Asked me all this question, and then I was trying to do a report and send it to him. So it was a ping pong, 20 ping pong, hits until the person was able to reason about the problem. If you have a comprehensive set of data, you just say, hey, I have a failing test, I have a deep link, can you help me with that? I don't even need to say I have a failing test. I just say, can you help with that? Then the person sees, okay, it's a failing test. And let's say I'm the one who is asked, I might say, I think I know the reason for that. I think it's related to a particular version of a dependency, right? Things are slow probably because of my, I'm using tether, no, I'm using the network here, so I'm not sure how fast it is. Stop watching videos here. So I think it's related to the version of HTTP client that we're using, right? But then I say, no, it's 4.5.10, that should work. So I had a hypothesis, and I can immediately see, no, that hypothesis is wrong. They're using the correct version. But then it dawns on me, I think I saw that problem before. I think it's related to Java versions, right? So I think that problem happens when I use Java 11 because the code base is still only meant for Java 8. So now I can look at infrastructure and can see, right, this build was using Java 11. So I tell the developer, hey, switch to Java 8 and this problem will be solved. Now imagine the following situation. That's one of my favorites, right? Let's say you don't have the comprehensive data. Your friend is asking you, can you help me with that test failure? And then you tell him, I think it's related to the Java version, right? What version of Java you're using? And the person thinks they're using Java 8. So they tell you, I'm using Java 8. Actually, it's not the case. The build was run with Java 11. The person was confused. You now rely on feedback, what they think has happened. And then and then you look in all these other directions. Maybe it's related to whatever, right? The Gradle version, but you knew the actual reason, but you had wrong data, so you had to move. And troubleshooting is very hard. We all know that. There's so many dimensions, right? It can be the cause for a problem, and when you then rely on kind of information what people think has happened, it's not effective, right? Okay. So one other thing I want to show you, right? Once you have all the data, you can do, you can of course look at aggregates, right? So you can look at trends. Let's take this for the Gradle project. So I can now look at how many builds are we running, right? Overall, local NCI. What is the cumulative time we spent on builds in the last 7 days? It's overall 421 days, right, that we were running builds and tests. And in some form, we had to wait for that, right? We're running a lot, but nonetheless, that's interesting data. Our average build time is 7 minutes and 7 seconds, right, for this project. But we also show you the percentiles, right? So the mean, the 95, so that you have an idea what is the variation. Then we show you per build, we save an average 13 minutes and 30 seconds because of caching technology. So, and that is, for me, so important. Let's say you make an initiative. Let's evaluate what is the benefit of a build cache, right? When you have the data, you can then make a strong business case. Well, it brought our build time down by from 20 minutes to 7 minutes, right? In average, right? And then you just have to multiply it with the build count, and you have a business case, right? But there's also interesting stuff, right? So when you think about a build cache, right, where you have to download things from a remote server, there's also some overhead involved, right? So in our case, the overhead of the build cache in average is 13 seconds, right? So it's a good deal, 13 seconds for 13 minutes, but it's good to also have an eye on that, right? And I could now go to performance, right, and could look at scenarios, right, where this overhead is very high. Maybe I have a team in San Francisco, or because they don't have a good connection to the cache. So that is all stuff I can figure out with this kind of data, right? Yeah. We also measure how long it takes per build to download the dependencies, all that kind of stuff. Who of you is doing ephemeral CI? Basically always throwing the CI agent away before they run a new CI build. Yeah. So people doing that, but then they cannot measure what impact that has, because you then now always need to download the dependencies anew, right? Things like that, right? So if you do those kind of changes, you want to be able to understand, well, if we do that to increase the reliability of CI builds, how much longer will the CI builds get because of that? So we talked about troubleshooting. So for me, one of the last things I want to show to you is also about reliability. If you think about it, right? I'm not sure what software you're all building, but I'm pretty sure most of you have some form of detection system that when a software that is used at a customer is behaving weirdly, that you have some form of notification system, right? At least you have some logging, you have some way to track that, right? So when you think about our tool chain, right? Let's say that's an example that happened at a company a couple of months ago. The infrastructure team was changing the configuration of the Docker file for the CI agents, right? And that has created a new failure that made 10% of all the CI builds fail. So in your organization, if that would happen tomorrow, right, what will be the workflow, the process until this is resolved? Let me guess. So this is now shipped, right? This is now the Docker configuration has changed. So the first developer is getting an email from Jenkins, CI build failed. So developer looks at the error message, some weird stuff, Docker image, blah, 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 saying, whatever, run it again, right? Let's wait another 30 minutes, okay? Same exception. Maybe developer decides, let's run one more time. After that, they will reach out to whoever is in the CI team. Hey, I have this weird exception. Can you help me with that? Sorry, I'm super busy. I will look at it later, right? Okay. The next developer, the same dance. The next developer, the same dance. At one point, 3, 4, 5 people complain to the CI team. Now the CI team think, oh my goodness, something is going on here. That might be 6, 7 hours after the incident was introduced, right? And I think we all agree this is so inefficient, right? To basically, you provide critical infrastructure and you have to wait for the users to complain about it. It's just not effective. You want to have some monitoring, right? You want to understand what failures are happening when I'm doing CI builds, but also local builds, right? So one thing that we are doing is failure analysis. So every build and test run that fails, locally or on CI, we capture the failure and we analyze the failure. The first thing we do is we classify the failure into non-verification and verification failures. The term build failure is unfortunately ambiguous, right? When you run a build and test and your test detects a defect with your code base, that is a successful build in my opinion, right? But we still call it a failed build. But actually, it's a successful build. It found a problem, right? So those are failures we call verification failures. And then we have non-verification failures. You run a build, you get an out-of-memory exception, or you get a null pointer exception, or something like that. So those are failures with the toolchain. And those are the ones we're most interested in. So amongst those non-verification failures, we categorize, we group together similar failures. And let me look at the last 4 weeks. So, and when you do that, you no longer have to wait for someone to complain. You can look every day at what kind of non-verification failures do I get, and then you can see something like here, right? Java null pointer exception, right? Every developer is freaking out, has no idea what's going on. Obviously something is wrong with the build, right? But you don't have to wait for them to complain. You can see here, wow, 290 builds have failed on February 20th, right? And then we show you more information. We show you 63 hosts were affected by that failure. So you know it's not just a problem of one specific host, right? So, and then here you have all the build scans, the data about the builds that run into those problems. So you know immediately, I have something to do here, right? You don't have to wait until something gets escalated. And you can see we're now working in a way we detect those and we fix them and they're gone, right? So, and I think for me that's also a big part of the maturity. You don't want to be reactive when it comes to the quality of your tool chain. You want to monitor it proactively. The last thing that I want to show is test failure analytics, right? So for me, this is a very, very important topic because you want to establish a healthy testing culture. And there are two things that are poisonous for a healthy testing culture. One is tests take a very long time to run. The other is tests are unreliable. They're flaky, right? That takes a lot of momentum from any testing initiative, right? We talked about it this afternoon. That gives an excuse for people not to write tests or to start ignoring tests. Oh, my pull request build is red. It's all a stupid flaky test. I merge anyhow, right? And then testing becomes more of a ritual. We pretend that we're doing test-driven development, but it's not actually, you don't get any of the benefits, right? So that's why it's so important to deal with test reliability issues, right? That's one reason why it's so important. So I want to show you an example. So we had it's the last thing for today. So when we are doing a release build of Gradle build tool, it's a build that takes hours and hours and hours. We have to test against every JDK, every platform, performance test, right? So that means if that build fails, we lose a lot of valuable time. We might even have to postpone the release by a day, right? So for us, what we did here, we said, hey, Gradle Enterprise, I make this a little bit bigger for this second. Show me all builds that were built from the release branch that were of type ready for release, right? And then, not show me all builds, but show me all failing tests that happened during that build. And then I see, oh, the main culprit, the main reason why that failed was this test. Then I look at this test, and I see all the test methods, and then I click this test method, which is the one with the most failures. And then I, for example, see something interesting. When I look at the failed tests, I can see that all the failed tests happened only on two agents, dev98 and dev97, right? When you look at all outcomes for the tests, you see Windows 36, Windows 40, dev73, right? So the failures are only on two agents. That's fishy. That tells me something. So now I want to dive deeper into that. So I go to the build scan, I look at infrastructure, and I see, oh, dev98 is a Mac OS X agent. And when we look at dev97, we will see exactly the same thing. So that data really helped me to figure out this problem, right? Before I even need to run the debugger or anything like that. I know this looks very likely to be a problem with this test on Mac. Let's say you are a Linux developer. You will stop trying to figure out why this test failed on your machine because it will not tell you anything, right? You know, you have spent a whole day trying to figure out why this test failed on a machine where you cannot reproduce the problem, right? So having all this data, right, is just is such a huge improvement to improve the mean time to repair a failure, right? What we also measuring is hold on. Oops, is flaky tests, right? So whenever a test fails, we run this test again, and if it's the second time successful, we send a signal to our database saying this was a flaky test, right? And then that's why. Sorry, let's do a refresh. And if you look at our own data, you can see that has helped us tremendously to avoid and mitigate flaky tests. You can see we had now weeks, although we run, I don't know, hundreds and thousands of tests. We had now weeks without a single flaky test. And it was one of the biggest problems our engineers were complaining about, right? Weeks. So from February 5th to February 16th, not a single flaky test when running probably hundreds of thousands of tests per day, if not more, right? And then you can see, but this is never a done issue. There's always, flaky tests always come back, right? It's, and you can see we had new problems, but we immediately could detect them, and then we could reduce them. So we show you exactly what are the flaky tests, right? What are the ones that causing the most of the build breakages, and again, extremely important data to have a productive environment where the tests provide you a strong signal, and people will not stop ignoring that signal. So that was all the demos I want to show to you, right? For me, a very important part of the data is to also have a discussion with management, right? So we were talking about that example, right? Many of you here have virus scanner enabled, I suppose, right? Or I don't know, but anyhow, I know quite a few organizations where this is the case. Maybe it's a trade secret, you're not allowed to share it. And I see many of those discussions, developers, when we go on site, they're kind of very unhappy. They're saying, oh, the stupid virus scanners, it makes everything so slow. But for the managers, those are just developers that are whining, right? That's what developers like to do. They like to complain, right? And it's almost an emotional discussion. The manager is kind of fed up with all those engineers complaining all the time. Developers are frustrated because it really affects them. But because there is no data here, it is an emotional discussion, right? So once you collect data from each and every test run, you can say, okay, let's do experiments, right? Let's run a build and test without the virus scanner, with the virus scanner, then multiply it with the time so often you run a build, and then you can go to management and not like, oh, we are so unhappy. You can just say, that virus scanner for our 100 people engineering team cost us 7 engineering years, right? And, or whatever, $1 million, right? And now you have a discussion, right? The manager might still say we have to do it, but he will say that with definitely much more respect and also feeling like, damn, 7 engineering years. Maybe we'll look for a virus scanner that is faster, right? Maybe there's something. It's not always binary, no, but it might be something. Once they see the pain in numbers, that might cause some creativity, right? And and we're seeing this all the time, right? That many of the CI teams, they are not incentivized by developer productivity. So again, sorry for telling you my stories the whole day. So we worked with that, and that's the last story for today. We worked with that organization where the CI team is supporting 5,000 developers. And that CI team got created for 2 purposes. to have a central place for security scanning and vulnerability scanning, and have a central place for auditing. So everything, every developer team had to use now their CI services, so that was now the central place where they could do all that stuff. So that was the incentive for the CI teams were those two things. So they went completely berserk, right? They increased CI build time by a factor of 10 by doing all their stuff, right? And they didn't care that develop, at least maybe personally they cared a little bit, but their management didn't ask them to make to make things better for the developers. Their management said, our job are those two things. So we often see situations where there are the wrong incentives and developer productivity is not part of the equation, so it gets completely ignored. If you can measure that and can show them, guys, this is costing us $40 million a year, and we're talking, with this organization, we're talking about that kind of money, right? I'm sure you will have a different conversation. So they went to a point that they said, let's run some of those scans twice, you never know, right? Because they didn't care, they had only one incentive, right? So that is a very important part, I think, for the evolution of software engineering, that you need to have the centralized function of developer productivity. It must become a metric that becomes relevant in your organization, right? So that people always try to measure what is the trade-off, right? And never completely ignoring developer productivity. It is still crazy. This company I was talking about creates software for a living, right? And yet, until today, right, they're still dealing with those issues and don't have the function of developer productivity as a core function in a company, and that's it's not good, right? Developers making jokes about it, right? But they kind of also surrender to that fact, and that's really an organizational failure in that case, right? So, and at one point, those organizations will be punished, no question, right? Because other organizations will do a better job. If you're more interested in that topic, there is a book that we have, an early access edition that we have published. It's called Developer Productivity Engineering. You can get a free version by just Google for Developer Productivity Engineering, you will find it. If you want to learn more about that topic, you can go to Gradle.com. We have trainings around developer productivity engineering, things like that. And yeah, thank you so much for coming tonight. And if you have any questions, more than happy to answer them. Yeah.
All right, so hey, thank you guys for coming out. Had a really great day with Hans. Thank you guys for coming out. It was amazing. I'm sitting over there going, oh my God, the CEO of Gradle is sitting here showing me the details of their internal build process and their metrics, and it was kind of a holy cow moment for me, sitting here thinking about how we like to talk about, dog fooding, and you guys are clearly a good example of walking your own talk,
yes,
and really applying those principles to improve your product and how you deliver and how you build. So thank you for showing us all that. That was very insightful. As always, I want to invite everybody to come join us for a lean coffee. We've got tables around the back. I'm really excited about someone as energetic as Hans getting into a lean coffee discussion. I think it's going to be a lot of fun. So again, thank you for coming out, and we'll break and do some lean coffees and a little networking. Thank you.
Awesome.